This question asks you to show there are no common solutions for those two polynomials. Okay. So we know z to the power of n equals to 1 plus I. This will give you n solutions, whereas z to the power of m equals to minus 2i. This will give you m solutions. Okay, so this one has n solutions, the other one have m solutions, and we're just trying to show they have no common overlapping areas. Okay, so none of them have exactly the same solution. So to prove this, we're just going to prove by contradiction. Yeah, so we're just going to show if there's a common solution, what will happen. Okay, so hopefully we'll contradict with some common knowledge, and then we can just say therefore they have no common solution. Okay, yeah, so just assume there is one common solution. Okay. Okay, so let's just try to express their solutions first. So z to the power of n equals to 1 plus I. We need to convert this into polar form. Okay, yeah, so the way to convert this into polar form is just modulus multiplied by modulus is argument. So modulus equals square root of real squared plus imaginary squared, and then the argument equals to tangent inverse imaginary over real, okay, for any a plus bi. Okay, so this will just become root 2 cis pi over 4 plus 2k1 pi. Okay. The reason I use k1 because for z to the power of m, I'm just going to introduce another k2. Yeah, and then k1 is any positive integers. Yeah, so z will just equals to root 2 to the power of n cis pi over 4 plus 2k1 pi all divided by n. Yeah. So that's z. And then let's have a look at z to the power of m. Again, we convert this into polar form. So z to the power of m equals to minus 2 minus 2i. If we convert this into polar form, this will just be 2 root 2 cis 5 pi over 4 plus 2k2 pi. Okay. And then k2 is another integer. So now we just divide, so raise both sides to the power of m over 1, so we can cancel this m out. So we have z equals to 2 over root 2, 1 on m. Sorry, that should be 1 on n as well. This one here should be 1 on n. Yeah, so 2 root 2, 1 on n. And then, yeah, cis theta all to the power of n equals to cis n theta. So you can bring n to the denominator. And this would be 5 pi over 4 plus 2k2 pi all divided by m. Yeah. So if there is a common solution, okay, if there is a common solution, means the solutions are the same. Yeah. Yeah. So if the two solutions are the same, so if R1 cis theta 2 equals to R2 cis theta 2, then the modulus must be exactly the same, and then the argument must be exactly the same as well. Okay, so we're just going to quickly equate the modular part. Okay, so by letting root 2 1n equals 2 root 2 1n. Okay, yeah, so just equating those two parts together. Yeah, so root 2 1n equals to 2 root 2 1 on m. Okay. Yeah, so we have 2 to the power of 1 on 2n equals to 2 to the power of 3 over 2m. Yeah, so they both 2 raised to the power of 1 on 2n equals 2 raised to the power of 3 over 2m. The index must be the same. So we get 1 on 2n equals to 3 over 2m. And we find the relationship between m and n. M equals to 3n. Okay, yeah. And then their argument must be exactly the same as well. So we're just equating the both argument together. So this argument, the box argument, must equals to this box argument. Those two arguments must be exactly the same. So let's equate those two together. So pi over 4 plus 2k1 pi divided by n equals to 5 pi over 4 plus 2k2 pi divided by n. And then we can equate m with 3n. Okay, so n becomes 3n. However, n and n cancelled. We can move 3 to the other side. So we get 3 pi over 4 plus 6k1 pi equals to 5 pi over 4 plus 2k2 pi. Yeah, so move all the k to one side and move all this pi to the other side. Yeah, so 5 pi over 4 minus 3 pi over 4, which is 2 pi over 4, which is a half pi. Right. And then we have 6k1 pi minus 2k2 pi. Yeah, so 6k1 minus 2k2 multiplied by pi. And you can see this is a big contradiction. Because at the beginning we assume k1 and k2. Okay, k1 is here, k2 is here. They're both integers. Yeah. So 6 multiplied by integer is integer. 2 multiplied by integer is integer. 6k1 minus 2k2, that's also integer. Okay, this is an integer. So integer multiplied by pi must be a multiple of pi. Whereas this side, pi over 2, it is a half multiplied by 2. Yeah. So your left hand side is multiple of pi, whereas your right hand side is not multiple of pi. Yeah. So you can see this is clearly a big contradiction. Yeah, so we just assume that there is one common solution, and in the end we can't find anything similar. Yeah, so this means there's no common solution. Okay, yeah, there is no common solutions.